Take a look at question 4. It says a class has 10 students and 4 of those students will be randomly chosen to give a group presentation. In how many ways can the group of 4 be chosen? Now, reading the question, we've got a couple key things to identify in on, right? When we think about picking these students, notice we're choosing them as a group. So one of the ways to think about this is, do I really have 4 quote-unquote events or not? And the difference here is we don't have 4 different events because the individual students aren't being chosen to do different things. They're all being chosen to do one thing. So it's really just one event. And that event is choose a group. So choose a group. And then let's think about what that group has to look like, where you're choosing a group of 4 people from how many people? Well, the total that we have to choose from is 10. And you might recognize this problem. We've done it before, but sometimes it's different when you do a problem in a slightly different context. When we did it before, we were in the section where we were learning combinations, so it made sense that we were using combinations. But sometimes when you take away the framework of that and we have to decide to use it, it gets a little trickier. So again, there's really just one event, and we're picking a group. We count that with a combination. The total number we're picking from is 10, and the size we're picking is 4. So then to compute that, we've got 10 factorial over 4 factorial. And then if you want to start to do this next step in your head, that's fine, because notice the next part is going to be 10 minus 4 factorial, and 10 minus 4 is 6. So if you want to jump to writing the 6 factorial, that's fine. So then start to write out 10 factorial. You get 10 times 9 times 8 times 7 times 6. And then notice once we hit 6, that's a number in the bottom, so we're going to put the factorial on it. So then that indicates the rest of the multiplication is still there. And then we're over 4 factorial, 6 factorial. So those 6 factorials cancel out. So all the numbers in 6 factorial get canceled. So then we're left with 10 times 9 times 8 times 7 over 4 factorial is 4 times 3 times 2 times 1. If you do 10 times 9 times 8 times 7, you get 5,040. And if you do 5 times 4 times 3 times 2 times 1, you get 24. So then we can take 5,040 and divide it by 24, and we get 210. Now let's actually go straight into question 5 from here, because it's kind of similar, and we want to compare the two. So question 5 says a class has 10 students, and 4 of those students will be randomly chosen. They each give individual presentations, one on Monday, one on Tuesday, one on Wednesday, and one on Thursday. In how many ways can the 4 students be chosen? So notice this time, there's more to the problem than just picking a group of 4 students. If we think about what events there are in this problem, well, really then we have to split it up based on days, because it would be different if, say, Bob presented on Monday and Joe presented on Tuesday versus Joe presenting on Monday and Bob on Tuesday. Those are different things. So even though it's the same people, the order that we choose them in matters because they're being assigned to different things. So we actually do have 4 events here. We've got Monday, Tuesday, Wednesday, and Thursday. So then if we think about, well, how many students do I have to pick from to put on Monday? Well, there's a class of 10 students, so I can pick from 10 of them. And then to pick for who presents on Tuesday, it does say that I have to pick 4 students total, so I can't repeat any of the students. I'll need 4 distinct students. So then we're down to only 9 options for Tuesday 8 for Wednesday, and 7 for Thursday. And we're doing sequential counting. Multiple events always means then that we're doing sequential counting, right? We're saying that I've got Monday and then Tuesday and then Wednesday and then Thursday. So we multiply those guys together, and then notice we actually did that multiplication up top. So I'll skip the calculator and just write down the answer of 5,040. So there are a lot more ways to do this problem than the problem before, and it makes sense because each set of students that we pick, really, then the orderings that we put them in are all different. So we're counting all of those as different from one another.